Hi again, welcome to the next section. In this section, I'll talk about why performance matters to users and businesses alike, and why performance is still a problem on today's web. Let's get started. When I approach performance in my own work, I like to think about it holistically, as one priority that we need to balance among other important priorities. It's easy to make a site fast if fast is the only priority we have to care about, but that's never the case. So I focus on the challenges and pain points at the intersection of performance and other priorities that we have to meet. And unsurprisingly, everything we do can impact performance. It's not just about code. Everyone who touches a site has an impact on performance. Any site can be made faster by stripping away its costly features. But we can't just make a site faster at the expense of features that are necessary to the business or to user goals. So it's that intersection, I think, where the hard problems are. So that's where I like to focus. It's been said that the web is a hostile medium to work with, and I think it's especially hostile to assumptions that we sometimes make. Some of those assumptions are that users and browsers and networks are certain to behave in a particular way or have certain characteristics. But things just aren't that neat on the web, because the web isn't any one reliable platform like you might expect in, say, app development. It's more of a continuum, to quote Jeremy Keith. A continuum of features and constraints. And I like this quote from Jeremy, but I also tend to think of the web as more of a scatter plot than a continuum. Instead of low-end devices supporting less and high-end devices supporting more, we get a messy mix of support and constraints across all devices. And there's just so much that we need to consider there. So let's talk about some of those features and constraints that we need to build for. Maybe most obviously today, our interfaces need to respond appropriately to a device's viewport size. And there's this incredible array of viewport sizes to consider today. When mobile devices first arrived, we often tried to divide them neatly into these categories like mobile and desktop. And from a viewport size perspective, that fell apart pretty quickly. Because across devices, viewport sizes have reached nearly a continuous gradient from watches to phones to e-readers, tablets, laptops, and TVs. So this part certainly is a sort of continuum. This graphic is from my friend Luke Wroblewski at Google, and it shows the Android screen sizes range from about 5 or 6 years ago. And I've always liked this graphic because it shows the folly of targeting any one size as mobile or tablet. And if this was updated for today, it would just be solid blue. So it's totally silly to design for any one viewport size as an example of that particular device category because they're just all over the place. So this kind of challenge calls for fluid user interfaces rather than a series of fixed designs. So responsive design is the tool, the practice that we use to address those viewport sizes today. Along with viewport size challenges, device capabilities are all over the place. This is an example of an app that I worked on a while ago, and I like that it shows progressive enhancement in action. At the time it was built, features varied really widely across mobile devices, and we would really heavily qualify the enhanced experience that we applied before we applied it. So this is the same page on the left and the right, and it's enhanced at different levels of JavaScript and CSS. And it's pretty extreme, actually, compared to what we do today, but I like that it illustrates this idea of qualifying the application of our enhancements to avoid breaking what we've already delivered. So even standard features can vary and are unreliably available across devices. Input and output mechanisms vary as well. Most devices offer multiple means of interacting with sites, between hardware buttons, software gestures, mouse, touch, assistive technology. We must be careful not to assume that any of those modes will be exclusively in play at any one time. Factors like screen size and, say, touch gestures also don't always correlate, right? We can't assume that just because touch gestures are in play that it's a small screen, because, of course, we know that's not true now with devices that support touch across all screen sizes. So again, our delivery of code needs to be smart to support these features in a way that qualifies their application and is ready to apply when features are supported. And all of those challenges impact performance because it takes more code to deliver across the continuum of devices, and more code tends to complicate performance. So we need to deliver and apply code judiciously and contextually. But there's another area I haven't covered yet that also factors into performance, and that's widely varying network behavior. And this is kind of the most common area where we focus when we think about performance today. And it's an area that's changing really quickly. When cell networks first arrived, internet connections were slow and really unreliable as a rule. According to Ericsson's mobility report in 2013, 60% of the world's connections were sub 3G, so edge connection or 2G, right? Fast forward to now, 3G is nearly 100% of population coverage. LTE is at about 70%, and 5G, which is the newcomer, is just starting to roll out, and overall networks are more capable now. But it's worth noting that these are possible speeds for a network to achieve, and rarely the actual speed that you really receive when you're connected to them. Congestion and latency cut into all of that and factor in, so you rarely get the speed that your connection is actually capable of. But even still, 3G and 4G coverage spread really quickly throughout the world, and now worldwide coverage is pretty decent. So we're all talking about 5G now. That's what's rolling out. A couple of months ago, I was in New York City, and Harlem's network was clocked at 1.4 gigabits per second, which is about 175 megabytes per second. So that's pretty amazing. But it's not just bandwidth that 5G will improve. It'll also improve latency. So it'll get that code turned around sooner and in bulk. So cell networks are getting faster, and in theory, that speed should alleviate a lot of the challenges that we have in delivering a lot of code faster. And it should, but so far it's not really happening that way. And part of the reason is that different regions of the world see connection speed improvements at different rates. And it's not just a difference of the developing world to the developed world. It's also more of a geographic divide within countries that are developed, like in the US. So LTE and 5G coverage is unevenly distributed. But another reason is that the average device that folks use to connect to the web today is relatively underpowered. Maybe relatively underpowered compared to the device that you have in your own pocket. And to be clear, when I talk about the average device today, I'm not talking about the high-end iPhones that many of us are used to using. It's actually phones like this one. The average device worldwide is the $100 phone, like this Alcatel One X or the Moto G and others like it. These are low-powered Android devices. Phones like this have not dropped in popularity despite the high-end phones getting more expensive. And that's because they're adequate and they're affordable. So even if these phones are connected to the same fast networks, they're very slow to process code that they download. So something that looks fast enough on a high-end phone might be prohibitively slow on an average device. How slow? Well, it turns out that these phones can take 6 seconds or more to process a megabyte of JavaScript. And that's after it already downloaded the code in the first place. Now, before we assume that a megabyte of JavaScript is more than the average, keep in mind that we're talking about 200 kilobytes of JavaScript transferred, and that unpacks to about a megabyte. So that 200 kilobytes of JavaScript traveling to the device is what takes about 6 seconds to execute when it gets to the device. So there are some big developer convenience issues to consider here. We may all be on the same networks, but the same amount of code that's delivered to different devices is taking a lot longer to parse. And since I mentioned 200 kilobytes, that may sound like a lot, but we're actually sending more than that on average to mobile devices. According to HTTP Archive, we're sending over 370 kilobytes of JavaScript to the average page. So that's closer to 2 megabytes uncompressed. And to be clear, this has been worsening. During the years 2011 through 2019, 4G coverage spread from 5% to 79% of the world. And during that same period, the median average JavaScript transfer size increased by 611%, from 52 kilobytes to 372.9 kilobytes. And in the time since 2019, the amount of JavaScript has gone up another 100 kilobytes. I think that correlation is pretty damning. Faster networks have enabled us to deliver increasing amounts of code, and it's causing the average device to choke. This is a major reason that performance is worsening for people on the web today. So as networks improve, we're shifting the performance burdens of the past from the network to the device. So right now, I think we have this huge opportunity to broaden our reach to many of the people who are now accessing the web for the first time. But it takes a lot of care to do that well. And it's up to us to use that opportunity wisely. And to be clear, it's not just JavaScript. We're sending more code overall year over year. And there are real and different costs to that increase in how much we're delivering. Some types of code that we deliver are more costly to speed, and some are more costly just to data consumption alone. But both of those are problems. I've always included these numbers in my performance talks, and these are from the httparchive.org again, and it says that the average web homepage these days weighs anywhere from 1.5 megabytes to 2 megabytes. And if I were to grab an updated stat on this even today, it's probably even more than 2 megabytes. This is always growing. And I should add that these are median averages. And medians are nice, but the thing about median numbers is that they tend to quiet the outliers at the end of at either extreme on a data set. And again, if we look at those averages today on HTTP Archive, we can see that it's gone up about 300 kilobytes on both desktop and mobile, respectively, since then. And many of the most popular sites on the web are heavier than that median. So weight is a real problem with data usage because most devices today that access the web over data plans have monthly or prepaid caps for speed or for access in general. So there's a real cost to every byte that's downloaded. And speaking of those costs, my friend Tim Cadleck built this really great site. It calculates the real cost of access of any site using the cost of data plans throughout the world. As an example, one article on the Wired website weighs over 11 megabytes, and that's pretty common. Not to call out Wired here, this is an unfortunately common thing in the news world today. And it says that for some people it costs almost $4 just to visit that page. So we know that we're making sites slower, and we know that slower performance is generally a bad thing. But just like other aspects of user experience, improving performance is not just about doing the right thing. It's measurably better for business too. And thank goodness for that, because it's hard to convince businesses to spend time and money on aspects that are not going to be a good return on their investment. Performance benefits are objective, and we have good business reasons to prioritize them. One great resource is this site called WPO Stats by Tammy Everts and Tim Cadleck again. And it's full of findings and statistics and quotes from companies that are really helpful in convincing your boss or client that performance is really hugely important. Like this one from Google's DoubleClick, for example, that found that publishers whose mobile sites load in 5 seconds earn up to 2 times more ad revenue than sites that load in 19 seconds, which sounds like a lot, but is actually pretty common. Performance also increases engagement. Google found that 53% of visits are abandoned after 3 seconds of waiting on mobile. So make a faster site, people stick around. And here's another. For every second it takes for the BBC's website to load, they found that they lose another 10% of their users. So every second is really critical. And in addition to just annoying users, poor performance also impacts findability in search. Starting in 2018, page speed became an official documented weighting factor for mobile searches on Google. So make a faster page, it'll improve your search ranking. So performance matters to people and businesses alike, and it's getting worse, not better, largely due to our own practices. So I'll end this section with one of my favorite case studies in performance. It's this blog post by Chris Zacharias, who formerly worked with YouTube. And in 2012, he wrote about this experiment that they did on the YouTube site, which was called YouTube Feather. And what they did was create a separate version of the site that was much lighter in weight. And they sort of tracked it like an A/B test to test against the regular YouTube site and see how well it did. And as they were watching the results roll in, they saw something that was really unexpected. On the new, lighter weight version of YouTube, the loading time overall distributed across all users was actually slower than the regular YouTube site. And they couldn't figure out what was going on there exactly. And at first they were kind of puzzled by this, but they realized after a little while that because the site was lighter, it was actually enabling people on slower connection speeds to wait it out and visit the site and use it. People who formerly just could not have the patience to wait for the page to load. So performance in this case was actually enabling accessibility. It was broadening their reach just by having a lighter page. So in this section, I covered some of the reasons why it's still challenging, even on a faster web today, to deliver a fast experience across devices. In the next section, we'll look into the metrics that go into the page loading experience and talk about why each of those moments and metrics in the loading experience can be slower than we expect them to be.